make the observation that this problem could be solved without calculus, because if you draw this line through this square, and by the way, I'm assuming that these vertices were labeled incorrectly in the problem definition, and that we're really talking about a square, and that we want the line through 2, 0 to separate the square into two parts of equal area. And if we draw such a line, we end up getting two trapezoids. And we could say we want the area of this trapezoid to be 1/2, because the area of the square is 1. Notice that I've labeled these points with coordinates 0, 2m, and this point with coordinate 1, -m. I did that by using the equation y equals m times the quantity x minus 2, which is the equation of this line, and substituting 1 in for x and finding out that y equals -m. So the area of the trapezoid, we could say, is 1/2 the height, which is 1, times the sum of the two bases, which is -3m. And if you do that and solve for m, you'll get the value of m that you have to use here. Now, if you really want to use calculus and an definite integral, the idea is that the area under this line would be defined by the definite integral from 0 to 1 of, well, here's the height of a typical rectangle. It's the y coordinate defined by this equation right here, y equals m times the quantity x minus 2. So if I distribute that m, mx minus 2m dx, we want the value of m that will make this integral evaluate to 1/2. So the antiderivative of this is 1/2 mx squared minus 2m is a constant. I'm not raising that exponent by 1 there. I'm just doing this. Evaluated from 0 to 1, we want that to be equal to 1/2. So substitute 1 for x, and we get minus 1/2 m minus 2m, and then minus the quantity. If we put 0 in for x, we're just going to get a 0. So we want this to equal 1/2. And I think you can see if you solve this equation, you get -1/3 for m, which is actually what I have the slope defined in this picture. Okay, so we're going to stop there. Hope that clears that up. And hope that helped.